From the phone.
Like get an adapter that will accept that you
That may be difficult because the executable is intended for the i386 processor. So you have to cross-compile that for your phone first. So that may be difficult.
Well, it's probably just as well that I don't, because then I've been doing that all the time.
Okay. All right, so I just want to show you guys the distribution of exam one, just so that you know kind of, how everybody else did in the exam. This is sorted by the score. So you can see that there are 2 people getting, 118.5% out of the entire thing because they got everything right, and I, basically deleted one of the questions. So, it bumped up, the score of everybody, except people who got zeros, they did not get much out of the whole thing. You can also see that there are now 4 people, so 2 people got extra credit, 4 people got 8 out of 8, which is 100% of the score. And then we have, let's see here, 87.5% is the quote-unquote cutoff for an A. But I don't do any type of letter conversion until the very end of the semester. So this is really just for your information. You kind of know where you sit in the grading scheme. So now we have about 2 people getting A's also. So combined with the other 6 people, we have about 8 people out of the entire class getting A's. And then as far as B's are concerned, we are going from about here all the way to 62.5%. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We have 14 students getting B's out of this exam. C's will go from, I cannot use a pointer to hover over because it will show the names, and that would be a bad thing for privacy. So I have to kind of scroll it from the edge. So everywhere from here, which is 59.25%, to 37, it's technically 37.5%, but I will count the 37.03% as a C. So we got fewer people getting C's and people getting B's, and then the rest of the class, kind of shown in red on the left-hand side. Those are the D's and the F's. I think 1 person did not take the test, or 2 people did not take the test, and that's why there were 2 zeros shown. And I'm not quite sure. Oh, okay. The other part is the homework assignment, so don't. The number on the right-hand side is not relevant for this discussion. So there are 3 people getting zeros, and then a few other people getting various scores for this test. Right? So that kind of gives you an idea of where you are in the class, and hopefully that information will be useful. And I have to go back again. All right, so now I can show the whole screen again because there are no grades shown anymore. I can also turn on the feature to show your ranking in class. Have I turned on that feature already? No? Okay, I can turn that feature on. So when I turn on that feature, you will see an additional number, which is X over the number of people in class, which is 40 something at this point. The lower the number, the better, because it means you're ranking higher in the class. So 1 out of let's say 44. Okay, I'm not sure whether it's actually 44 or not. If you see a number like 1/44, it doesn't mean your score is 1 divided by 44. It means you're ranked first out of 44 students. So I can turn on that feature. I do not use that for grading purposes. This class is not graded on a curve. So it's all absolute grading, based on the cutoff points that we have already talked about in the syllabus. With the first exam, because I deleted one question, so everybody got like a 18.5% increment, out of your original score. All right. Any questions? No questions? All right. So what we'll do is we'll go back to the really boring stuff that we were doing the other day. I'm pretty sure some of you still remember what we did the other day, which is our Scratch program. We did all this, so far just to validate the input, but I can also use this, to keep track of, what letters have been guessed or not. It all depends on how hard you want to make the game. If you want to make the game, so that if people guess the same letter again and again, and they will just, the hangman will, or the hang person will get more strokes, that's actually an easier program to write. So you're punishing the player for not inputting the correct data to begin with. But the way I'm doing it right now is try to be as kind as possible. All right, so now we have this program works up to a certain point at this point. So let me just go ahead and run the program again. And it can validate, like, 0 doesn't work because it's a digit. You can also try to input like whole words, like word, and you click. It doesn't work because it has more than one letter. So it only takes the input when you input one single letter. Like in this case, let's say B here is a single letter, and you can see that used letter is now B, and it will remember the letters that have been used already. But you can type B again, and it basically just says B is used again. So that may not be what you want to do. It depends on how harsh you want to make the game. Are there any questions at this point? No questions? Okay. And I really like your solution of having individual buttons. So did you create 26 sprites for the letters?
Yeah.
Did you use a script to create those sprites?
I did not use a script.
I don't think there's a way to do it that way. There's no way to manufacture sprites. It would be nice if it did. Yep. So you have to create the individual sprites.
Yeah, and each one had like 3 blocks of code on its own, but it was pretty small, so it didn't take too long.
Did you have to duplicate all the code between the sprites?
No, but I had to edit them all.
Okay.
A little bit.
So it's still a little bit tedious.
Yeah.
Yep. Okay. But that's a very good idea from the perspective of user interface, because you basically just eliminated this whole problem that I'm trying to deal with here. All right. Okay. So what we want to do today is to change this block of code so that we can utilize used letters and valid chars, and those two will be related to each other. In other words, if I guess the letter B, I will add the letter B to used letters, but I will also remove that from valid chars because it's no longer a valid input. Okay, so we'll go ahead and try to see how we can modify this program so that it will behave this way. What do you think I should do first before I try to do this kind of surgery on an existing program that works up to a certain point, even though it's not like 100%? Save it first, right? Now this is a beginning programming class. We do have some students here who have programming experience already, so you know what I'm talking about. But to the rest of the class, the whole concept of back up your existing code before you work on it may be foreign, because we may not have the experience of suffering from the consequences of doing that. Because occasionally, I would say not so occasionally, I would make changes to my own programs to a point where it doesn't work anymore. Okay, it was working okay, it was working partially, and then I make some silly changes to it, and then it just breaks the entire program, and I have no idea which one of the 20 changes that I have made broke the program. So that would be bad, okay? And that's why we have a mechanism called revision control in the real world. But this class, we are not going to talk about revision control. We'll just go ahead and back up the program under a different name. Okay? So this is what I'll do. I'll just go to File, and this time I use Save As, and change the name. Well, I'll go back up one level, create a new folder for today, which is 2012-10-25. And I don't understand why in the United States people do not use the year before the month, because for sorting purposes, this makes more sense. When you sort dates using this particular format, it's all looking correctly. But if you use month, day of month, and then year, and you sort it just using the letters, it doesn't come out right.
Same reason why we use imperial measurements.
Well, imperial measurements sometimes make sense, because I kind of like the binary aspect of it. You can divide it by 2, divide it by 2, divide it by 2, because you can get to very fine measurements without using a lot of tools, because you can use just is it a compass? The tool that you can use a compass to get all the way down to really fine measurements. Decimal sometimes actually makes less sense.
I'm not a big fan.
But the entire world needs to agree on whatever base we want to use, be it base 7, right? All right, so I'm going to save the program first. So I will save this program as hang person. Now, when you save a backup of a program, I know your file system can keep track of the last modification date and time. I would put the time onto the file name anyway, just so that you can look at the file name and okay, this is a snapshot of the program on this particular day. Or if you make modifications during the day, also make the time a part of the name. So in this case, I will just name this. If I don't expect to change it any more, next year, I can probably just use the month. But if I want it to be more complete, I'll just use today's date. And if I really want to be kind of picky about this, I can also put in the time, which is 10:41 in the morning right now. So that makes the file name really, really long. But at the same time, it helps me find out what the program is. But then I have to reopen the file because the file name right now is the really long name. So I have to reopen the file to be the one from yesterday. So, I can just reopen this one and then resave it. And this time as just in hang person, which is the current version of hang person. So now I'm ready to make modifications. I saved the old version already. In the real world, there are tools that we call revision control software. Now, revision control software is very nice because it allows you to compare 2 versions of the same code. Okay, now we are talking about text files here. So it can display the differences. It can tell you exactly how the 2 files are different. Oh, you added this line here, you deleted these three lines down here, and these 2 lines are modified, they're changed. Okay, so using that kind of tool, out of a file of several thousands of lines, you can quickly, easily locate the 2 lines that you have changed. So I think those are very useful tools, but in this class, we are not going to use those tools. Are there any questions about what I have just talked about up to this point? It's basically, maintenance or, just stuff that you should do to keep track of your programs. No questions? Okay, well anyway, all that stuff will become important when you get to the next class. Sorry, no drinks in the class. Okay, sure. All right, so let's go ahead and try to change this program so that we can keep track of the used letters and the valid letters. So those 2 are now related. Okay, the first thing we have to change is over here. Okay, look at this. We have a really long condition here. Let me change the display here. We have a really long condition. Okay, can anyone remind me what this condition is all about? The length of valid chars is less than I, or letter I, or of valid chars equals to answer. It's an until condition, so the loop will not exit until this becomes true. So what does it mean when this is true? When I is greater than the length of valid chars, or letter I of valid chars equals to the answer.
Make sure that you only enter
wanted a correct character.
and then make sure that character lies within the letters, which is the variable valid.
Okay, go ahead.
I was just saying that if that becomes true, that means you've inputted the correct amount of characters, in this case 1, and that also appears in the valid characters list of what's an acceptable character.
Okay, you're close, and I think you got it. The first condition, which is length of valid chars is less than I, means I is no longer a valid index into the array, which means I have scanned through the entire array and I cannot find a match, which means it is not a valid char in that case. It's one reason to get out of the loop is when I have confirmed that whatever the user have input is not one of the characters or one of the valid input. The second condition, which is letter I of valid chars equals the answer, means, hey, you know what? I just found a letter within the array that matches the input, which means, oh, it is a valid input, it is fine. So those are the two reasons why I'm getting out of the loop. Okay? But if I want to change the program so that it keeps track of the valid chars and basically remove one letter when it is used from valid chars, I can no longer get out this early. I have to kind of, well, I suppose I can finish it. I can finish it this early, but I have to do some work after that to keep track of what characters I still have to use, or what characters can still be used and what characters have been used already. Okay. Sometimes it is better to rewrite the entire program, okay, from scratch. Okay, you might have situations like that in your next class too. If you have to make extensive changes to your code, especially the structure of the code, sometimes it's better off just to restructure the entire program in a different way. Do you guys want me to modify this one or just start from scratch? Because I think in this case, starting from scratch may be a better idea.
Wouldn't it just be, wouldn't a valid way to do it is if you enter something that is valid, it removes that character from...
Yes, but it changes the way I scan for the, it changes the structure of the loop. Okay, let me just save this one. I'll go ahead and write a new one based on this one. So I'll save this one and open a new one. Oops. Start a new program. I think it's already new, that's fine. Okay. So we'll go ahead and start a new program. We still have some of the same things that we have to do with as last time. And I'll start with the first one is valid chars. And then I make another variable called used chars. Okay. I should have used letters because the term char or characters refers to anything, okay? Punctuations, digits, and letters. If I use the word letters, it means it has to be A to Z. So I'll go ahead and change the name of my variables and see if I can change it. It doesn't let me do it.
You have to delete.
Yeah, that's a bother. All right, let's do it again. Okay, but how about this? Unused letters. I think that's a better word. And I'll make another one called used letters. All right. I could have named these two variables x and y. Would that be a good way to do it? I mean, less typing.
Remember what they are. This way confused track of what...
Exactly. You should try to name your variables so that it is quote-unquote self-documenting. In other words, just looking or reading the name of the variables will remind you what it is about. Okay, if I named these two as x and y, it would not have made much sense. And then I would, throughout the programming cycle, I would have to remember, oh, x means da 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 da, and y means da 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 da. But when I name it like this one, when I name it like these two variables, when I look at the variable name, I know what they are about. Right? So the first thing I want to do is to initialize unused letters. As the name implies, it's unused. So how should I initialize unused letters in a game of Hangman? A all the way to Z, right? Okay, so we'll just go ahead and initialize it like this. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, Z. All right. And what about the other one, used letters? It also needs to be initialized, because if I do not initialize, does anyone remember if I have a variable that is not initialized, what is the initial value? It's always 0. So we have to make sure that this one doesn't start with 0. So we'll just remove the 0 here to make it an empty string, and obviously change the variable to used letters. Okay, very good. So now we got the 2 variables initialized. And then the next thing we have to do is to, we'll handle 1 letter at a time. In other words, I'm going to make this program so that it will only accept 1 valid letter and add it to, remove it from unused letters, add it to used letters, and that'll be the end of the program. Because I want to make it simple to begin with. Once I get that part up and running, I can always put it into a loop and then put that into another loop and so on. Okay? So this type of programming is actually called bottom-up programming, because I'm actually working with the lower level part of the code first instead of the top level of the code first. And I will even make an assumption that, well, I don't need to make an assumption. Actually, I can just do it like this. Go to variables. I'm going to make a new variable. And this new variable is a Boolean. And its name is just input is valid. In other words, this is a Boolean variable. And its only job is to keep track of whether the input is valid or not. So we'll go ahead and also have it initialized here. And I will have it initialized to false, because I will make the assumption that the input is invalid to begin with until I find a good reason to say that, oh, okay, I guess the input is valid after all. Okay. I need to go to sensing and ask the question. And the text of the question will just be very simple. I'll just say, enter an unused letter. That will be the prompt. And now we have to dig into the logic of this code. Now, if I want to keep track of used letters and unused letters, the easiest way to do it is to go through the entire list of unused letters and see if the input is one of them. Okay? And as I go through the list, I will stash the rest into another array. And then at the end of the whole thing, we'll just swap the two arrays so that the temporary array will become unused, and then vice versa. Okay. So that means I have to make myself another variable here, and I'll just call this one temporary unused letters. And with any type of variables, you have to think about the initialization. So in this case, my new variable called temporary unused letters will be initialized to an empty string, because I'm going to construct this string as we go through the entire unused letter string. Are we still doing okay so far? Okay, all right. How am I going to go through the entire unused letter string? There's a quick and easy way to do it. If you go to control, can anyone tell me which one of these constructs would allow me to repeat the same action to every single letter in unused letters? Okay, well, we can go ahead and just go through the entire list here and see which one may be usable. When the green flag is clicked, nah, it's not going to be very useful. It's only good for starting the script. When space key is pressed, not going to be useful. It's only good for starting the entire script. When sprite 1 clicked, same thing. Wait 1 second, doesn't really do anything. It's not a repetitive type of thing. Forever is a loop. But I don't think I want to do this forever. Okay, I want to get out at some point. Repeat 10. That looks promising to me. Broadcast, not going to work. When I receive, it's not going to work. Forever if is still forever, because you can see there's no tab here to continue the operation. Not going to be very useful. If and if else may be useful because they are conditional, but they are not repetitive. But I have to do something repetitive. I have to do something to each and every letter in unused letters. So the conditional statements may be useful, but not at this point. Wait until, not going to be useful. Repeat until, maybe useful. Okay. What do you think? I want to match the answer of the input to maybe one of the letters in unused letters, but I have to scan through the entire thing anyway. So if I have to scan through the entire unused letters string, or array if you will, which construct would give me the easiest way to do it? Repeat until, okay? Now, we are down to two choices here. Let me just pick the two choices here, and then you guys can kind of help me evaluate which one is a better one. On one hand, we have repeat a certain number, and then on the other hand, we have repeat until a condition is true. So which one do you think may be suitable in this case? This is actually a very tricky one, so you might want to think a little bit about it first. Because in addition to doing something repetitively, I kind of have to keep track of the position of the letter within unused letters. If I use repeat 10 or repeat length of unused letters, yes, it will do a certain operation the number of times, same as the number of letters in unused letters, but I still have to keep track of the variable to keep track of which letter I'm looking at, and repeat count is not going to help me with that. And that's why, in the end, we are still going to be stuck with repeat until.
Question.
Yes?
Can't we just repeat it every time and a certain amount of time, then we get out?
Well, you have to keep track of the index. In other words, in the first iteration, you look at the first letter of unused letters and try to match it to the answer. Mm-hmm. In the second iteration, you have to look at the second letter and try to match it to the answer. Yes. So you need a variable to kind of keep track of which position within unused letters you're dealing with, which also means since you have to keep track of that variable anyway, you can also use that variable to help you decide when you can get out of the loop. Okay? So we'll go ahead and use repeat until, and we need one more variable to keep track of the position within unused arrays. Now in this case, I can use the word index to unused letters. I'm trying to make my variable names as self-describing as possible. So now we can set that variable to 1 to begin with, because unlike in our pseudocode in all practical programming languages, Scratch starts counting from 1 when it's dealing with the arrays, because most people start counting from 1, and I guess they make a decision like this to make it easier to learn for most people. Unfortunately, this will just help some people develop a bad habit of counting from 1 instead of counting from 0. So you just have to be careful when you move on to the C++ class. All right, so index unused letters is starting from 1. Now I have enough information to decide when I can get out of the loop. What do you think I can use here to decide when to get out of the loop? Which comparison operator should I use? I can use either less than or greater than, because I can flip the two sides. So let's just say that I use greater than. What should I put on the left-hand side of greater than? The index, left-hand side. What did I put on the right-hand side? When do you think is the index invalid? When it's greater than the length of unused letters. So we'll just go to operators again, locate length of, and then use unused letters, like that. Okay, repeat until index unused letters is greater than the length of unused letters, because if it is greater than, that means index unused letters is no longer a valid index and I should get out. Is that making any sense so far? Kind of? Yep, go ahead.
How does this account for the actual answer?
Say again, please.
How would this account for the actual answer in the long run?
It's all going to be inside the loop. So I'm just setting up the structure here so that I can look at each and every letter in unused letters. Okay. All right. Next thing I have to do, certain things I have to do anyway. In this case, I have to change index unused letters by 1 for each iteration. Is that making any sense? Because for the first iteration, I look at the first letter. In the second iteration, I want to look at the second letter. In the third iteration, I want to look at the third letter, and so on. So that means for each iteration, I have to bump up the value of the index by 1 to prepare it for the next iteration. Is that okay? All right. So this loop will exit, and the program will end. It just doesn't do anything. You know what? I'm going to test the program right now, even though it's not very useful. So I'll go ahead and put an end to it, and run the program. Okay, I run the program. It's asking me for an input. You know what? I can input anything. The program will still do exactly the same thing because it's not doing anything with the answer to the question. You don't see the answer bubble anywhere within the script, which means the answer is not used at all. But you know what? I have to make sure the program at least ends, and by the time it ends, I want to make sure the index unused letters is 27. And it is performing what it is supposed to do at this point of this program. So that means I'm not testing the program after I get it to working condition. I'm testing the program even before it is even meaningful, just to make sure the control structures are set up correctly. It's not an infinite loop, because if I don't test it frequently like this, it means by the time I really test it and it doesn't work correctly, I will have to scratch my head and say, okay, I just added 50 lines to this program. Which one of these lines is responsible for the program not behaving correctly? On the other hand, when I perform this type of testing, after adding 5 lines of code or something like that, I know pretty much, it has to do with the last 5 changes that I made to the program. So that's why I'm testing the program more frequently, rather than just finishing the whole program and say, cross all my fingers and make sure that it works. Try to wish it works, okay? But that doesn't work in programming. All right, so this is working so far. And what do you think I have to do inside this particular program? Okay. Now, for the sake of making this program easier to read, I will introduce another variable. Now, I know this variable is not strictly necessary, but it does make the program easier to read. Okay. So I'll just say 1 letter. Okay, 1. Okay. How about this unused letter? In other words, I'm focusing on one single letter in the unused letter list and try to do something with it, okay? Because this way it's easier to deal with. And I will have a initialization code inside the repeat until to change, I don't need to run it, to change this unused letter to one of the unused letters. Can anyone tell me how I should initialize this unused letter? Which variable do you think is serving as the index to a particular unused letters in this program? Just using the names of the variables, which one do you think is the index to a particular unused letters? Index unused letter, right? Okay. And out of all the operators here, which one do you think will get me a particular letter out of all the letters? Letter blah of blah, right? So we'll go ahead and pick that operator, stash it into the place where it's supposed to go. But then the index, let me change the size of the screen. The index is not one which is a constant. I want the index to be the index variable. And I don't want it to be indexing out of world, which only have 5 letters. I want it to be indexing out of unused letters, like that. Is that making any sense so far? Okay. So, you know what? I want to test the program right now. I want to make sure that it is actually getting to the right letter. It's scanning through all the letters sequentially, because I just want to make sure that is the case before I make use of this unused letter in this program. There are two easy ways to do it. If I run the program as is, I can look at the letter from here and see that it is changing from A to Z. Okay, maybe I should just do it this way and see if it is obvious. Maybe magnifying the whole screen will make it more clear. In other words, I want to keep track of this unused letter and make sure that it goes from A to Z in this particular program. Click the Run button. Whatever I input doesn't really matter. So, okay, it's a little bit quick, but I think it went from A to Z. Are you guys convinced?
Yeah.
Okay. If you're not convinced, now I have to. If you're not convinced, you can go use put a weight. Put the weight down here. But waiting 1 second is going to be too wasteful of time. So you might want to just wait like 0.3 seconds so that we can go through 3 letters per second. So we go back to the full screen mode, run the program, input a letter which is not used at this point. And now you can see, it slows it down to show you that this used letter is going from A to Z. So I'm feeling kind of comfortable that I now have a mechanism to scan through all the letters within the unused letter array. Are we doing okay so far? So I'm testing the program very frequently just to make sure that changes that I made to the program, one, did not break the program, and that those changes are working correctly. All right. So getting back to the script, now I feel comfortable. So this is the other part of using Scratch that's kind of cumbersome because I cannot make quick changes and just take out one little block. Okay, so the next thing I want to do is to potentially make changes to unused letters and used letters. How do I decide whether I should remove this unused letter from unused letter and put it into used letter, or do nothing about it? What kind of test should I make? See if it is the answer, right? So now I can go to Control again, and this time it is a one-shot thing. In other words, I'm not trying to make another loop in here. I just want to see, what I should do with it depending on the condition. I personally would always use if-else, okay? Because if there is nothing to do with the else branch, you know what? You can just leave it empty, right? It just looks kind of funny with one branch not having anything to specify. But if later on you change your mind and say, oh, you know what? I forgot. There is something to specify for the else. If you had used just if, then you have to remove the block and then introduce the else, which is a whole lot of headache. If you use if-else to begin with, you can always specify something in an empty branch later on without a whole lot of work. It just looks kind of funny without anything to do for the else at this point. Is that making any sense? Okay. So the condition that we want to evaluate is a equality, because I want to check whether the answer is this unused letter. Okay. But now it's really easy to do, because when we go to operators, we just locate the equality check, put it here. We go to variables. It is very nice that we have a variable just to say which unused letter we are looking at this point. Because if I didn't have this particular variable, I would have to put the entire letter blah into that particular slot. And the program reads better too, with this intermediate variable. And what should I compare that to? Go back to sensing, which is a big clue already. What should I compare this unused letter to? Answer. Because answer is the input from the user. So I just put it here. All right. Well, that's pretty easy to do. Okay. If it does match, what do I want to do here? Okay, remember the names of the variables. What do you think I should do to unused letters? I should remove this letter from unused letter and put it into used letters. Okay, so we'll go ahead and see how we can do this. Adding it to used letters is really easy, because the way you do it is to use operators. Oh, go to variables first, and then you say, I want to change a variable and set used letters to, and then you go to operators, and you just have to join its old value with the letter that we have, that we are dealing with right now. So we are joining used letters with this unused letter. Or you can use answer because we know they're the same at this point. No. Okay. This unused letter goes here. There we go. Okay. That's one thing we have to do. What about skipping skipping this letter in unused letters? Now, skipping is not as easy. There's no way for me to delete one letter out of the entire unused letter. And that's why we have the temporary unused letter. So that means I don't have to do anything about this letter. So that means, with the else condition, if this letter does not equal the answer, I have to copy it to the temporary unused letter. So I'm going to be a little bit lazy here, duplicate this, and stash it here. Except in the else, I don't have to do anything with used letters. I have to do something with the temporary unused letter. So I can get rid of this, and then put this one here. All right. In other words, this letter remains unused because it doesn't match my answer. Okay. Is that okay so far? Let's test it. Okay. I think I have added enough logic to this code to warrant another test. What should be the behavior this time of this program? In other words, if I give it a correct letter, what do you think it should do? If I add, go ahead. In used letters, and then temporary unused letters should have that letter missing, and everything else being there. Okay, so we'll go ahead and test the program. Now you can also see how important it is to design your test properly and also know what the answer is supposed to be before you test it. It makes no sense whatsoever if you don't know what the answer is or how the program is supposed to behave. It makes no sense to test the program because there's nothing to compare the behavior of the program to. Okay, do you guys have a question over there? No? Okay. So let's try not to talk, because that can be distracting. If you do have a question related to the class, raise your hand, and I will try my best to answer those questions. All right, so let's go ahead and test the program again. And this time, it does matter what I put in here. So I'll just put in something that is, a valid input. So I'll just input C. Now, before I press the check mark, I'm going to say, okay, I know what this program is supposed to do. Used letters should be C. And then temporary unused letters should be A, B, D, E, F, and so on, skipping the C. And unused letters should remain the same because, we didn't do anything about it. We didn't change it. So we'll go ahead and check, click the check. And that's exactly what it did. Used letters has a single C here. Temporary unused letters has A, B, D, E, and everything else being there. And unused letters is just, unused letters. In other words, the program seems to behave the way it is supposed to. What if I input something that is not a valid input? Let's say putting in 5 as a digit. What should be the behavior of the program in that case?
It should just ask me again.
Well, this code does not ask me again, because it's a one-shot thing. It doesn't even try to validate it in the input. It should not make any changes, right? So used letters should remain empty. And temporary unused letters should be the same as unused letters because everything is unused at that point. So we'll go ahead and run the program with that case. So I'll use a 5, which is a digit. It is an invalid input. Run the program again, and you can see that used letters is still empty. And then you can also see that temporary unused letters is exactly the same as unused letters because it couldn't find an entry to match it. Are we doing okay so far? Does everybody understand, what I'm testing and how I'm testing the program? right. So now I feel comfortable. Now, if I were to write this program for a class or to turn this in as a homework assignment, and taking a class, this is like my first programming class, I would have saved this program several times under different names already. Okay, but since I'm teaching the class and I feel fairly comfortable that I'm not going to mess up the program too badly, I didn't do all the backups. But you should be doing some backups as you go through this programming assignment. All right, next we have another variable that is initialized, but it was never used. Input is valid. What should I do about input is valid? And if I'm going to do something about it, where should I do something about it? If you look at the conditional statement, which branch is telling me that the input or answer is valid? It's okay. This is, we can proceed with additional processing after this point. The then branch or the else branch? The then branch, correct. Very good. So what we want to do here is to have another set statement under the then branch. And there are several ways to do this. I can do it this way. It works. Change to true. Because if this unused letter is the answer, in other words, I find a match in the unused letter string, I know the input is valid. Is that making any sense? Okay. And then the other thing I can do after we get out of the loop is to basically say our unused letters is now the same as our temporary unused letters, which may be one letter short because we had a valid input. Is that making any sense? Because otherwise we are not making changes to unused letters. Is that okay so far? Let's test the program again. Make sure that those two variables are affected correctly. So we run the program again, maximize the screen, and once again we'll test it twice. Test it once with a valid input, test it once again with an invalid input. This time I will pick K as a valid input. Okay, so it is all done, and you can see that unused letters has A, B, C, D all the way, but K is skipped, which is okay. That's exactly what it's supposed to do. Used letters has just K, which is also what it is supposed to do. What about valid? Input is valid is true, which is correct. Okay, so we'll test the program again with an invalid input this time. So we'll go ahead and test it with 6 as a digit. The program is now done. You can see that in unused letters, it has all 26 letters. Input is valid is false. Used letters is still empty. So the program is still is also working correctly. Well, that gives me a warm and fuzzy feeling that I can continue with the rest of the program. Isn't it very tedious to test the program a little bit and then add some more code and then test it again and then add some more code?
It's a lot less tedious than missing out.
That is,
trying to find out what you went
that's the whole point of doing this. Is it seems tedious. It seems like it's a waste of time. I cannot possibly make mistakes with that kind of a simple program. You know what? Those are usually called famous last words.
You completely screwed up. That's all that time wasted.
Yep, exactly. A lot of times, the screw up can be very simple. It's in most cases, a screw up is using a less than or equal to instead of a less than. Adding one, whether to add one before an operation or add one after an operation. Those are the little things that can actually make the entire program blow up, or it will blow up at a boundary condition, which means only very certain cases will trigger the problem to manifest itself so it's visible. Okay, so let's go ahead. Now, technically, I should really be testing the program using the letter A and the letter Z because those are quote unquote the boundary conditions. One is the first and one is the last. Okay, but I didn't, yep.
Pass on the roll sheet.
Yes, I will pass on the roll sheet. Thank you. Thanks for the reminder. Here we go. Okay. So I feel comfortable with this program. Now I can see if it can handle a repetition In other words, I'll just be asking for an unused letter, keep track of the unused letter, and keep asking again for another unused letter. So I'm not even playing the hangman game yet. I just want to make sure that the mechanism of keeping track, what is used and what is unused will work in an iteration. Because so far this is one shot. I have only tested this, logic in a one shot, manner. I have to test it in a loop manner to make sure that it does remember and make use of, used letters and unused letters correctly. All right. So this time, what should I use? Let's see, there are several ways to do it. The most general way is to use a repeat until mechanism. Okay. And what should I put inside this repeat until? Now, I know that we have to copy or cut and paste a bunch of code into that repeat until, into the body of that repeat until. Where should I start the copying? Now, obviously, we should not copy from when the green flag is clicked. How about these two initializations? Should I include these two initializations into this loop here? No, because we don't want to reinitialize unused letters and used letters for every iteration. What about input is valid? Yeah, we want to double check. So for every iteration, we want to reset input is valid. So I'm going to put this entire, well, almost the entire thing, except the stop script cannot fit inside. So I'm going to put this entire portion here into this loop, stash the loop into here, and then put the stop script back here. I have not specified repeat until. You know what? If I just want to test this program right now, I can just specify true here. It doesn't let me enter true, so what should I do? What is the? Well, actually, I want to turn this into an infinite loop, which means I want it to be. I think it's inherently an infinite loop at this point. Okay, so that's okay. It's inherently an infinite, which means if you leave the blank space here not specified, it is the same as false. Okay, does that make sense? Repeat until false is an infinite loop. When do you think false will become true? Never. So you never get out of the loop. Okay. All right. So we can now test the program. This program will never exit. That's actually the proper behavior. But what I really want to do is to test. Okay, if I input C, which is a valid input this time, we can see. Oh, it's too fast because it went all the way back to the beginning to reinitialize false. So I'm going to stop the program and change the prompt a little bit here. So I'm going to make the prompt before the initialization of input is valid, and then put the rest back into here. There we go. It just makes the program easier to debug and visualize. Okay, so we can now input the letter. Let's say input the letter C, and you can see that it considers C as a valid input. C is now a used letter, and it is now missing from unused letters. Just like when we tested the program earlier. Now I want to test the program again. What if I tried C again? Okay. It should show false, but what should happen with used letters and unused letters? They should both remain unchanged. Okay, well, we should test it. See, this is important. You have to know what the program is supposed to do first before you test the program. And that's exactly as we expected, which is good. Okay, now let's try something that is valid again. Okay, remember I should test the boundary conditions, A to Z. So let's go ahead and try Z, which is the last letter. And it works because you can see that Z is now missing from unused letters, and it is now a part of used letters. Okay, so now we have a mechanism to make sure that we can keep track of what is used, what is unused, and also whether the input is valid or not. Are we doing okay so far? Okay, excellent. Now would be a good time to save the program again. If this is my homework assignment that I have to turn in, I would save the program again and probably write some comments, just to remind myself, how well or up to which point this program is working at this point. Because if I just save the program, it doesn't really tell myself, okay, this program is working up to this point. The logic is valid up to this point. So I should write some comments too if I were to save this as a snapshot of the program. All right.
Wondering where would you put the comments?
Oh, the question is, where would I put the comments? In this case, because Scratch doesn't really let me enter comments, I'll just, stick maybe a say statement or a thought bubble at the end of the program. Just use it as a comment.
I saw something like that. If there was an edit or file or something like that.
Okay,
There
let's
was a
check.
checkbox.
So we'll go to File, Project Notes. Okay, that's great. Okay, excellent idea. So I can basically use Project Notes and put down the date and the time. So today's date is 2012, 10/25. And then the current time is 1125, and I can just leave some notes to myself. We can say the program can now track used letters and unused letters. Click OK, and then save the file under a different name, or close the program and then copy the file to a different file name. Okay. I would never copy the file when it is open, because when the file is still open, even if you save it first, you really don't know quite sure. You're never sure whether when you make a copy at that point, whether it really is the closed version of the program or not. So I would always close the program first, and then make a copy, and then reopen the file again. Are there any questions at this point? Is anyone thinking, I have to rethink whether, computer science and programming is really my thing or not? No? Go ahead. Oh.
No, but saying yeah.
Yeah, this is really just, a fairly simple algorithm too. It gets much worse from here. Okay. Next thing we want to do is to introduce a word that we are trying to guess. Okay? All right. So now we have a big block of code here, and it's just really a big block of code. What should I do next, to introduce, the actual game, the hang person or hangman, logic, which is, to guess the words and update it and keep track of, which costume I should be in. What should I start with? I now have a mechanism to validate the input, to get to a particular input. I think the first thing I should do is to introduce another loop so that it will keep looping until I have a valid input. Just like what we did last time. Is that okay? That is relatively easy to do because I already changed it to use repeat until. So I can just say repeat until and go to comparison, logical operators. Put an equal symbol here, go to variables, and then I can just specify repeat until input is valid. So I have to take these two out of this block here. So I have to specify valid is input equals true. And then I have to specify some other logic too. So I have to take this block out, put it outside the loop. Wait. Nope, this still goes here. But the initialization of input is valid has to be done before the loop here. And then the rest I can put it outside too. And then put this back. These two belong inside the loop too. There we go. So I have now changed the program a little bit. It will keep asking me for an input until the input is in fact valid. Well, let's double check. Unused letters is initialized once. That's right for the entire program. Used letters is initialized once for the entire program. That's right. This entire code here will probably turn it into putting inside yet another level of a loop, but we'll do that later. Because right now, my focus is just to make sure that the program will keep asking me for an input as long as I give it something that is invalid.
Does it need an or statement then for the losing scenario if the player loses?
Oh, I have not even put in the logic to guess a word, because right now I'm just checking and validating the input. I just want to make sure the program can keep asking me for an input until the input is valid. Okay. All right, so let's go ahead and run the program again, and I'll keep giving it something that's invalid. Okay, a digit 5. It's asking me again. 5 is not put into use letters, and it is considered invalid, which is correct. Put it like a long sentence, the gibberish. It's still not good. Give it a single input. Okay, give it X here. It is considered input correctly. X is missing from here. It is put into use letters. So the program is working the way it is supposed to. It keeps asking me for a valid input until the input is actually valid. Okay. So what have I done so far? I have implemented just the logic to input one valid input letter. we haven't even started with the logic of the hangman logic. Okay, so looking at this code, being like, wow, this is really kind of long already. I'm going to start another script, leave this one alone, so that way I don't have to confuse myself too much with because this is just the logic to get one single letter, which is a guess. But I now want to focus on the logic of the actual hangman game itself. So we'll go ahead and revisit this code later on, and we'll go ahead and start with the hangman code down below here. So when the space key is pressed, it will start the hangman logic. Yep.
This will be recorded, right?
That's a good question. I think it's getting recorded. The question is it a silent movie? And the answer is, it's good.
Okay, good. 'Cause I might have to watch it again later.
I think it is good to watch it again. I might watch it again. All right. In fact, I will probably put this on YouTube and actually tag it correctly with Scratch instructions.
Okay.
Yeah, because I think people other than this class can also watch it and maybe learn something out of it.
So I'll watch that. You can actually do it.
Yes. If not for anything, it's a cure of insomnia.
Yeah.
I'm having problems sleeping. Okay, just turn on tactile screen recording. 2 seconds you're out. No chemical products. No side effects whatsoever. No diarrhea whatsoever.
Yes, but is there a risk of becoming addicted to the substance? Yes.
You may be addicted to programming, right?
No, you can't sleep until you get the books.
All right, so now we're focusing on the logic of the actual hangman game. Now the actual hangman game is also kind of complicated, okay? Because if you think about it, let me just kind of write it in mousepad first. Okay, so now we know how to input one single letter. The question is, what do we do with that letter in the game? So let's say we are talking about the word feed, F-E-E-D, okay? The first thing that you have to do is to say, okay, we need to have another array to represent the partial guess, which is okay, which part of this word is actually guessed correctly, because that part has to be displayed. Okay. So now we need 2 arrays right away. One array is the actual answer, and the other array to represent the partial word that is being guessed at this point. Okay. So we'll start with the variables in this case. So going back to Scratch, I'm going to create myself 2 additional variables. So one word is, I'll just call it the answer. And the other one is the word that I'm guessing. So this would be, I guess, I call it partial answer. Partial answer. Like so. All right. And for the sake of this program, I'm going to initialize one of these to a known word. Okay, I'm not even going to randomize or use a list of words here. So I'll just go ahead and make this simple, this logic really simple. And I'll say set the answer to a known word. Since we have been using feed, for a while, we'll just use feed. And by the way, FEED feed is also a valid hexadecimal number. Sorry? Feet? Okay, we'll use feet then. It's close to lunchtime, so I'm changing it. Okay, feet, which is not a valid hexadecimal number. Because it only goes up to F. All right, so now we have to think of a way to initialize the partial answer so it has the same number of letters as the correct answer itself. Yep.
But you were programming this thing so that one letter will be repeating only once, but here we have two E's. So
we are not even dealing with that yet. Okay,
really?
so
Okay.
Yep, we're not even dealing with that. Okay, so now the question is, how do I initialize? Okay, getting back to Scratchpad here, how do I initialize the second array, which has the same number of letters or the same number of slots, except they should all be underscores or some unused punctuation to represent these are empty spaces or empty slots for a letter to go into. So how should we do that initialization? That's the question. What do you think? Do you think that's going to be a loop of some kind? Okay, very good. So let's go ahead and look at control and see what kind of loop we should use. Now, I think by now you know that it's either this one or down here this one. So the question now is, do we need that one index variable to keep track of the position that we are looking at when we are initializing partial guess or partial answer? Actually, we don't, because every single position is going to start with either a space, underscore, or dot, okay, or asterisk if you will. So we'll go ahead and use, just repeat a certain count, and then we'll make this count the length of the answer itself. So we'll go to operators and specify length of, go to variables, and then specify the answer. And then for each iteration of this loop, we're going to add one letter, append or join one letter to the partial answer variable. So that means we have to use the set operation, and we are going to change the variable called partial answer so that it is the join, which is an operator of partial answer itself. And let me maximize this part. And a single dot or a space, whatever letter you choose, it's okay. You just have to use it consistently. Okay? And then I can specify the end of this program. You know what? This is enough for me to say, well, I'm not quite sure whether this program is working the way it's supposed to. Let's test it. Okay? When I test this part of the program, what should happen as far as the variables are concerned? I should see 4 asterisks in partial answer. Okay? Nothing else should get affected. All right, so let's go ahead and see whether that's going to happen or not. Oh, I click the green flag. Stop. Actually, press the space bar to trigger the second part of the program, just the second part. Oh, man, I forgot one thing, right? What did I forget to do? Initialization. Exactly. So that means I have to do the initialization before or in the loop? Before the loop. Very good. So I have to use the initialization before the loop and set partial answer to nothing. There we go. And then maximize the screen again, press the space bar. Ah, okay, better. Okay. In fact, I can press the space bar again every single time. It still worked correctly. Whereas before, it just makes it longer and longer because I did not initialize it back to nothing. All right. Well, now that we have that, we have the initialization, we can actually get into the game now.
Sweet.
So almost two whole lectures after the the initial discussion of the game, we can now finally get into the actual logic of matching letters with the word itself. But you know what? That part is actually pretty easy because we have done it already. Okay. So what are we going to do here? I'm going to kind of hard code this whole thing, at least for the time being, and just ask a question. Go to sensing, ask a question after the loop, because remember this loop is only for the initialization of partial answer. So I'll ask a question, and then what I need to do is to scan through the entire correct answer, and then when I do have a match, I have to change the partial answer to reflect that particular letter. And remember, hey, this letter is good, okay? Don't draw another stroke of the hangman, okay? Should that process be repetitive, or is it a one-shot kind of thing? It's repetitive, okay? Because I have to look at each and every letter of the correct answer and match it with the input guess and see if it's a match. If it is a match, I have to change the partial answer. Okay? But I can't just change a letter in the partial answer. I do not have a way to change just one thing out of the entire thing. So that means I have to use, guess what again? I have to use a temp variable so that I can reconstruct the entire thing every single time. But before we do that, I'm going to give myself okay, I know for sure it's not going to work, so never mind. All right, so we'll go ahead and use a loop. And this time with this loop, do I need an index variable so I can see which letter I'm dealing with in the answer? I do, okay? So whenever I need an index variable, I might as well turn it into a repeat until type of loop instead of just repeat count. Now I need another variable. Now I know I could have used index unused letters, but it's bad practice to use a variable that has a name implying it's doing something and you make it to do something else. So what I'll do is I will make another variable in this case, and this time is an index to the answer. And we'll go ahead and initialize that before the loop. So set index the answer to 1. And then we put a loop after that. So go to control, and then we have repeat until after the initialization. Oh, there we go. It should never fit over here because it doesn't have a tail end. All right. So we'll do the same thing as before. We'll go to variables, and then we change index the answer by 1 inside here. And then we have about the same thing as last time. We have a comparison for the loop condition. And we say that if the index is greater than the length of the answer, then it's time to get out. Is that okay? In other words, with these lines here, everything from set index the answer to 1 all the way to the end of the loop itself, I have just set up a control structure so that I can go through and look at each and every letter of the answer. That's all I have done so far. Is that okay? All right. And before I add any more logic, do you think I need a conditional statement inside the loop? In other words, for each letter of the answer, I'm going to do something this way or the other way depending on something else, depending on the condition. Is that making any sense? Because we might want to match the input character or the input letter with a particular letter of the answer. If it matches, we do something over here. If it doesn't match, we do something else. Is that making any sense so far? Okay. So we'll go ahead and just add that logic. And once again, whenever I know I need to use a conditional statement, I just automatically use if then else, so that if I do not have anything to do with else, I just leave it empty. But if I do have something to do, I can just populate it at that time. We have seen this logic before already, because what we need to do is to look at one single letter. Oops, and I'll do that first. I have to match something. What I'm matching is one single letter controlled by index the answer of the answer with something else. What am I matching it with? I actually already have one variable to represent that, I think. Maybe not. Okay. Well, in this case, in this particular logic, it really is just the answer. So I'm just going to match it with whatever I type in. I'm assuming that I'm typing in something valid, okay, because I already have the logic to validate the input. I'll incorporate that into this later on. Okay. What should I do if it does match? Okay. How about this? Before we decide what to do with it, I'll just use say so that I can tell whether the logic is working or not. Okay. So I'll all right. So I'll go to looks here, and then say found a match, and we'll make it pause for 1 second so we can look at the variables at the time, so we can check whether it is actually making the correct match or not. And for the other one, we'll say not a match, and we'll make it wait for 1 second. So, and we'll test the program. So we go maximize the program, and spacebar. Okay, I forgot to change the prompt. Okay, the word is feet. Okay, so I'll go ahead and try any letter. Okay, remember this time I don't even have any validation of the input, so I can type in anything. I'll just type Z and see what happens. Okay, not a match, not a match, not a match, not a match, and then the program ends. That's good. Okay, this is what it's supposed to do. I'll do spacebar, run the program again, and this time I will input something that is a part of the word. I'll try F first, okay, because it should match only once. And it says found a match, not a match, not a match, not a match. That's good. I'll run the program again. This time I'll guess the letter E because it should appear twice. In other words, I should see not a match, it is a match, it is a match, not a match again. Not a match, found a match, found a match, not a match. So the program is working up to this point. It can differentiate whether it is actually a match or not. All right, so we'll stop and then go back to the program. And before we, stop today's class, I still have 2 more minutes. I can add at least this much logic to it. What I can do is I can go to all right, so this is what I'll do. I am going to use partial answer. This is not the correct answer, but it will give me an idea of, oh, this is getting close to what I want. So I'm going to go to the set operation here, and I will set partial answer to the join of partial answer now, because if I do find a match, the other part here should be the answer itself, and then I'll duplicate this code, put it here, and this time no, don't run it, stop, take answer away, and then put an asterisk here. So this program is still not working the way it's supposed to, but it's all right. We'll just run the program again and see what it's going to do. Maximize the screens, press the space bar. All right. Now we need to know what the program is supposed to do first. Okay, we are not reinitializing partial answer back to an empty string, so we're only going to make it longer at this point. If I put E as my input, how do you think partial answer is going to change this time? Exactly, it will have one asterisk, two E's, and then another asterisk, because the two E's are the matches. Okay, so let's double check and make sure that's the answer. Not a match, found a match, found a match, not a match, and that's exactly what it did. It appended the new partial answer to the old partial answer. But that's an easy problem to fix. Okay, I think we can fix that problem relatively easily. But at least we know the program is on the right track. I now have the logic to match the input to the word that the user is guessing. Okay, so next time we meet, we'll have the third installation of the hang person program. Okay, and I'll see you guys over the weekend. Have a nice weekend. I'll see you on Tuesday. I got your test.
Oh, right. So I